Okay, let us begin with the next discussion. I think in the last class I had stopped at a point where I was talking about how I can make sure that conversion of linear queue to circular queue is done by a bit of modification to the ordinary queue. Okay, has anyone got the solution for it? Please be true to yourself. Make sure that you are not referred any book, you are not referred any Google link available. You are telling your answer on your own. Okay. Anybody has got the solution for it? Please let me know. Okay, Puttaya, you have commented upload today's and yesterday's class. Definitely I'll do that. Okay. Thank you. Then if Q naught is empty, yeah.
First, ma'am, you can read, ma'am. After that, I will say.
Okay, if Q0 is empty, if yes, then re-initialize R to 0 and insert till F is equal to R. Okay, Srinivas has given me a solution. Yeah, who else is speaking?
Ma'am.
Yeah, go ahead.
There might be two ways, ma'am. In both ways, first we will check if the user wants to insert, ma'am. First we will check if the front is less than or less than rear or not, ma'am. Because, ma'am,
okay,
in this condition, we will get to know that the queue is not empty, ma'am.
Okay.
After that, ma'am, we will initialize the front. We'll insert elements like front minus front, ma'am. We will insert the elements backward.
1 minute, Praveen. Okay, I'll share the screen first of all. Just pay attention for this. After I have inserted, after I have deleted 2 elements, 3 elements or 4 elements, whatever you want, I'll delete this, I'll delete this, I'll delete this. Okay, front will be here, this will be front, and this will be rear. 50 will be rear. Okay, now what I will do, I'll insert 60, I'll insert 60, and I'll insert 70. Okay, this is a point where we stopped. Okay, now front is at 40, that is at 3, and rear is at 1. Okay, Praveen, in this situation, front is greater than rear.
Ma'am, we will not go by this method, ma'am. Sorry, ma'am.
Yeah.
But like, ma'am, at this position, rear equal to 4, ma'am, and front equal to 3, ma'am.
Yes.
So now we will check one condition, another condition, that if front is less than rear, ma'am. So Q is not empty, ma'am. Now nothing to do. Just like, ma'am, we will insert the element like minus front. So it will new element will be inserted at second position. Then after that, one
when you are inserting, 1 minute, when you are inserting, you are not supposed to touch the front.
Okay, ma'am. Okay, ma'am. So in the second method, ma'am, we can do like after every insertion, ma'am, we will declare a pointer, ma'am, array, ma'am. In that array, we will copy those elements first, ma'am. If simple insertion is there, we will copy that all the elements of the queue in that pointer, ma'am.
Okay.
So normal display and pop function will be there, ma'am. If the condition like front is less than rear and we have to insert, so we are going for the circular queue condition, ma'am, that you asked, ma'am. In that condition, ma'am, we will copy the elements of the queue in like, ma'am, string reverse, ma'am. We will reverse the order.
In another array.
Yes, ma'am. In another array that we declared first, ma'am. So
okay, but again, that is a tedious job.
Ma'am, if the condition is met, now if front is less than rear, then only we are doing this.
Okay, what I will do, in 100 positions available, I will go on inserting 100 elements. Then I will delete 50 elements and try to insert 50 more elements. So, yes, your solution is correct. I don't have any issues with the solution that you have given. But the only problem that is associated is again the time.
Yes.
Okay. Yes. Good try. Any other? I just wanted this class to be a physical class, okay, offline class. Well, anyways, um, any other solutions? I'll give you 1 last minute of time. Okay, I'll give you a hint. Fine, I'll give you a hint. Whenever you are trying to increment rear or increment front, the increment of front and rear are in such a way that when they reach 4, after I increment rear, it has to come back to 0. There is a modification done in the increment. How do you increment rear normally in the linear queue? I will write rear plus plus, or rear is equal to rear plus 1. Now, if I want to have a specialized increment operation, okay, that specialized increment operation has what is called as mod operator. Okay, can anybody guess based on this? You have to increment in such a way that it has to come back to 0 using a mod operator. No? Okay. Let me just go ahead with the solution. Okay, somebody has commented. Let me just see that. Front equal to size minus 1 or rear equal to size minus 1. Then go to the declaration. Okay. Nice tries. Very nice tries. Any other solution? I've given you a hint. Very important hint I have given. You just have to increment in such a manner that increment by 1 and apply mod operation on that in such a way that it has to come back to 0. Okay, let me just go through. Suppose that all of you please pay attention. Once you understand this, that's it for the, yeah, somebody has commented. Let me just see that. I'm just finding it so interesting to talk to you. Rear is equal to rear plus 1 mod size. Wonderful, Yogesh. How I have to do that? Let me just cross verify. Okay. See, I'll write 4. What is the value of rear now? 4. Before inserting 60, the value of rear is 4. Okay. Now the rear has to come back to 0. How I can do that? 4 plus 1. As usual, I don't change that. Okay. 4 plus 1 is 5. Mod size. What is this size that I have given? Size of the array. Okay, let me just cross verify that. 4 plus 1 is 5. 5 mod 5 is 0. Similarly, it has come to 0. Imagine 0 plus 1 mod 5. Okay, mod 5. 0 plus 1 is 1. 1 mod 5. Any number lesser than 5. I'll retain the same number. 1. 2 plus 1 mod 5. 2 plus 1 mod 5 is 3. 3 mod 5 is 3. Okay. So in this manner, I will go on incrementing front and rear. Both front and rear are incremented using the mod operation. It is as good as writing rear plus plus in bracket mod size, or I'll write rear is equal to rear plus 1 mod size. Front is equal to front plus 1 mod size. Then if I do in this manner, I hope this is clear for you guys. Let me just write it in the chat box. I want to increment rear. I will do it like this. Rear is equal to rear plus 1 mod the size. Similarly, if I want to increment front, front is equal to front plus 1 mod size. The value be 100, size of the value, the value of the size be 100, 2000, 3000, whatever it is. It will range between the 0 and n minus 1. It will not cross that when you apply the mod operation. This is the beauty of, this is the use of mod operation actually. Okay, it is not actually getting the reminder. It is actually, this is the application of the mod operation in any of the applications. Okay. Now, if I take it like this, the movement of front and rear are okay. There is no problem at all. They will move very freely from 0 to 4, then come back to 0, then go back to 4. This will continue, not an issue. But what about overflow condition? What about underflow condition? If a rear pointing to size -1, can I call it as overflow condition? You cannot call it, because rear can come back to 0 again. Okay, so what will be the overflow condition? What will be the underflow condition? Can anybody comment on this? Think different. Only then you will understand this. Think differently. How you can think of, or in what way you can think that there are ample number of elements in the queue, and that's why I cannot insert any more elements. Okay, there are few comments. Let me just read that. Can you explain percentage in front condition? Surely, I will do that, Praveen. Then use loop to check if any element is null. Okay, if E is empty. Srinivas, E is empty is not. It is not a built-in function. E is empty, you are creating on your own. It is user-defined function. I have to define that. What is the condition which defines E is empty condition? So let me explain the percentage symbol on front. Okay, let me do that. I will just discard this for a while. And let me just share the screen again. Okay, where is front, where is rear? At this point, I have not deleted any element, I have not inserted any more elements. Front is at 0 and rear is at 4. Correct, you are right. Now, at this point, I want to delete an element. Okay, I want to delete an element. What I will do, instead of deleting, instead of simply doing front plus plus, I will do front is equal to front plus 1 mod size. Right now front is 0, 0 plus 1 is 1, mod size of the queue is 5. 1 mod 5 is 1. So front gets incremented to 1. Next time, if I want to delete, now 10 gets deleted. If I want to delete 20, okay, front has to be incremented. Front is equal to front plus 1 mod size. Front is right now 1. 1 plus 1 is 2. 2 mod 5 is 2. So this gets deleted. Similarly, I will continue up to 4. Okay. Now front is at this position. And say, let's suppose rear has come to this position. And at this point, I have inserted 60. Okay. Right now, rear is at 0. Front is at 4. Okay. Now, if I want to delete an element 50. What has to happen? Front is equal to front plus 1 mod size. Front is 4. 4 plus 1 is 5. 5 mod 5 is 0. So front has come back to 0. In this case, also, whenever front and rear are equal, or whenever front and rear both are pointing to the same position, then it is assumed that there is exactly one element in the queue, similar to the linear queue. No change in that. But overflow and underflow conditions definitely vary, because front and rear can occupy any position. There is no restriction. Between 0 and size -1, front and rear can be anywhere. There is no restriction, unlike the linear queue. So then tell me, what can be the solution? You don't have overflow condition or underflow condition using front and rear. There has to be something else. What is that something else? थोड़ा pressure डालो अपने brain पे. Okay? Only then you will understand it. Can you think of zara hatke solution for this? You cannot take front and rear into consideration for checking overflow underflow or empty condition. What is the way out? How I can find Q is empty? Yes? You want me to tell the solution? Let me tell the solution for this. Okay, quickly. Praveen has commented, loop for checking whether all elements are null. No. No. Think that a bit ahead. Whatever option you are given, Praveen, make that a bit of ahead of thinking. Instead of checking null, the entry, instead of checking the element present at that point, you have to check something else. Okay, I'll give you a solution. I'll give you a hint. As and when I insert an element, into the circular queue, I will accommodate one extra variable for any of the operations. You can accommodate that as part of the structure itself. Okay. Along with the front, rear and the queue array, I will take one special extra member of the structure that is called as count of the variable. Okay. So can you think how I can have insert operation done, how I can have delete operation done, how I can have display operation done? Can you just think of that? Now, Praveen, can you comment? So what my structure will be having? Structure will be having front, rear, array, which contains the elements, then a variable which is called as counter variable. What this counter variable does? Just pay attention. Whenever I insert a new element into the queue, this count has to be incremented. Whenever I delete an element from the queue, count has to be decremented. So count initially has to be 0 on an empty queue. So the overflow condition is whenever count becomes equal to the size of the queue, I will tell that queue is overflowing. Whenever count becomes 0, I will tell that queue is empty. Okay, so along with front and rear, I will take a counter variable which is called as count, which gets incremented every time I insert a new element, which gets decremented every time I delete an element. Okay, let me just cross verify that whether it works or not. Okay, let's check that. What I will do is, I'll remove all these things for a while and let me start inserting the elements. What is front, what is rear? Quickly, at this point, what is front, what is rear? All elements are not there, I have queue empty. What is front, what is rear? Front 0, rear -1, correct. So next I will insert the first ever element. Before you insert the next element, how do you go ahead in the rear increment? I will do rear is equal to rear plus 1 mod size. Okay, rear right now is -1 plus 1, -1 plus 1 becomes 0, mod size is 5. 0 mod 5 is 0. So rear gets incremented as 0. Next I will insert say 100 or 10, whatever element you want to insert. Okay, I have inserted 10. After this, whenever I insert a new element, along with the rear increment, I will do increment of count. Okay, so count initially was 0, now it has become 1. Then I'll insert 20. So rear gets incremented, rear becomes 1, then 20 gets inserted and count becomes 2. Similarly, when I insert 30, 40, 50, count becomes 5. Okay, this is 30, count becomes 3, 40, count is 4, 50, count is 5. Now if I try to insert a new element, count is 5, which is equal to the size of the queue. Queue is overflowing. Queue is overflowing. Now if I want to delete, I'll delete 10. Whenever you delete, decrement the count value. Count value has become 4. Delete 20. Now the count value has become 3. At this point, rear is at 4, front is at 2. Now if I want to insert a new element, count is not equal to the size of the queue. So I can accommodate an extra element. Okay, so 60 if I want to insert, rear gets incremented by 1 and then the mod size. 4 plus 1 mod size. 5 mod 5 is 0. 5 mod 5 is 0. So at this point, at 0th position, 60 get inserted and count has become back, or it has come back to 4. Then I'll increment rear again and insert 70. And whenever I insert, increment the count has become 5. At this point, if I try to insert any more elements, it will tell me, no, queue overflow, you cannot insert. Now what I will do, I'll start deleting again. 30 gets deleted. 30 gets deleted. Then 40 gets deleted. Then 50 gets deleted. Okay. And then I will do deletion of 60. So front has come here. Deletion of 70. Front has come here. At this point, front is over here. Rear is over here. Rear and front position doesn't matter for me. What is mattering for me? Every time you delete, the counter has decremented and it has come back to 0. Whenever count is 0, I will tell that circular queue is empty or underflowing. Any doubt at this point? Please let me know. Please let me know. So what is the overflow condition? What is the underflow condition? Overflow condition is count equal to size. Whenever count is equal to size, I will tell it is overflowing. What is underflow condition? Whenever count equal to 0, it is underflowing or queue is empty. So other than normal queue, other than front, rear and the array, I require one extra variable counter which holds the current number of elements in the queue. This is how circular queue implementation is differing from the ordinary queue. Any doubt at this point? Please let me know. Implementation of this, I will take it in the tomorrow's class. Okay. So any doubts? Please let me know quickly. No doubts? If no doubts, then I will end the session for today. How will display function work? Same way, you have to start displaying from front to rear, and the condition for emptiness is count equal to 0. We will see, that is also a trickier one, Srinivas. Tomorrow when I start implementing this program, you will understand this. Okay. So tomorrow morning 9 o'clock, when we see this program, we will see the implementation of the same thing that we have discussed today. Fine. Shall we stop today? Okay. We will end the session. Thank you. Thank you all. Tomorrow, we'll see for the circular queue implementation. Thank you.